This video covers data definition language and data manipulation language. This is 8.3 in the CIE 9618 Computer Science A-level spec. Firstly, we're looking at the data definition language. So with a DBMS and our database, users' applications don't directly manipulate the files on the storage. They have to go through the DBMS. So all structural operations like creating the database, the tables and the fields is done through the DBMS using a data definition language. And the DDL defines, modifies the structure or schema of the database. So we're building up a picture of the whole database and how it's organized and structured in one place. Remember, this is one of the advantages of using this approach compared to a file-based solution. And the SQL for this kind of thing includes create, alter and drop. So they're DDL statements, the create, alter and drop, because they affect the structure of the database, not the content. So the DBMS acts as an intermediary, interpreting the DDL and updating the underlying schema data dictionary accordingly. Let's have a look at data manipulation language. Again, users and applications don't directly access the data stored in the database. They have to go through the DBMS. They use the DBMS's data manipulation language, and the DBMS works out how to access the actual data, partly using the schema and data dictionary that's been set up using DDL, and can access the actual physical stored data. And DML includes things like the queries, which is to retrieve data, and maintenance, inserting, updating and deleting records. So DML operates on data and DDL operates on structure. And one thing to be aware of is confusing updates with alter, because they sound very similar, but alters is to do with the structure and update is to do with the data. So the DBMS as the sole route to data means that we can enforce invalidation rules, we can enforce referential integrity, access right, and implement concurrency control on every query or update, rather than those being left to the individual applications. So this is a much safer and easier to manage approach. We also get consistency across users and applications. So we can have lots of front-end programs or users submitting DML, and the DBMS guarantees a consistent enforcement of the rules, regardless of which application issued the request. So SQL is structured query language, and this is an industry standard language used by relational DBMSs to implement both DDL and DML. So both of those are covered by SQL. And rather than each DBMS vendor inventing its own proprietary syntax for defining structures and manipulating data, SQL provides a common standard language that works, albeit with minor dialect variations, across different systems. So for example, Oracle, MySQL, PostgreSQL and so on all use this same kind of approach. And SQL is governed by an ISO ANSI standard, meaning the core syntax and semantics are agreed upon across the industry, rather than being tied to one particular company's product. So it means that database design skills and code are portable. If you've learned SQL on one system, you can transfer and work on another one quite easily. You don't need to be completely retrained on the different systems. It also means that different database management system products can interoperate more easily, and organizations aren't locked into a single vendor. So let's have a look at some DDL. Here we're going to create a database from scratch. So the first thing is create database. So that's a piece of DDL. It's affecting the data dictionary, the schema of the database, and to saying there is a database called, in this case, school. So we have no data yet, we just have the fact in our schema that there is the whole thing is the database called school. Then we're going to create our first table within the database, and here we're creating a a data table called teacher. And we define the attributes and data types of the fields within the table. Again, this is just structural. There's no actual data yet other than the data dictionary itself. So we create teacher and we say, for example, teacher ID is an integer data type and teacher name is a varchar data type with a maximum length of 30. We also put in there primary key. This is a CIE approach. There are different ways of writing this, but we've written down a separate line with primary key, brackets, and then the attribute or field that is the primary key, in this case teacher ID. And we put those sort of things in brackets, and we end SQL statements with semicolon. These are the data types we have, at least for CIE, which is a character, a fixed length text of n characters, varchar, a variable length piece of text, maximum length of n, boolean, which is just true or false, an integer is a whole number, reals a floating point number, and then we have date, which is calendar dates, and times, which is time of the day. Continuing by looking at DDL, we'll look at the alter command. So alter table changes the structure of an existing table. In the first case there, we're altering the table to add a column. So we're saying add column email. So it doesn't change the data that's already in the table. It's just changing the structure of the table by adding one. It is possible to drop columns as well, and that removes data. But basically what we're saying is there is no longer a column in the data dictionary called that if we drop the column. We can define foreign keys for tables. So when we're creating a table, we can specify foreign key, linking it to another table. So in this case, we're linking the enrollment table to the student table, and we're using a foreign key of student ID. So for CIE, we say on a separate line, foreign key followed by the attribute that is the foreign key and references the other table. So you need to name the other table, in this case student, and the field or attribute on that table that it links to. So student ID is the primary key of the student table, and in this table, the enrollment table, we are using a foreign key of student ID. Okay, so we have that attribute on both tables. Here in enrollment, it's a foreign key, and over on the student table, it's the primary key. Okay, so add can be used to add new attributes to a table. Alright, so here's a little bit more. Following some steps. First of all, we create the database, then we create a table called teacher, and then we're creating another table called course, and you would just do this for all the tables you wanted in the database. You can see there that we've got primary keys. Primary key on the teacher is the teacher ID, and then on the course table we've got the primary key of course ID and a foreign key of teacher ID, which is referencing the teacher table and the teacher ID table. So that's linking this table back to the original via the primary key. Some common mistakes. So you might miss field names. You might forget the field name in brackets after primary key or foreign key. So don't forget those brackets and put the name of the primary key in there for CIE. Missing references. So when you're creating a foreign key, don't forget you need to use the word references, then the table that's where the primary key comes from, and the field name on that table. You may use the wrong data type. So for example, you might be using text, which is used in some databases, but here we're using varchar. And missing length, you might forget to put the length on varchar, so don't forget varchar, then brackets and n. You always need the length on a varchar. And incomplete altered table, so you might forget to use the add or drop column keywords. So add a column or drop a column. Now, querying databases. So this is DML rather than DDL, or data manipulation language. Of course, it's still SQL, and as far as SQL is concerned, as you know, it's all the same. They're just SQL commands, but we differentiate between the DDL and the DML. So using the select command to find data. First of all, we specify what attributes we're interested in. So in this case, we're selecting name and grade. If you want to select all attributes, then you just use a wildcard, which is asterisk. And then we're saying which table it comes from. So in this case, from the student table. And we can optionally specify a where clause and where limits which ones we get. So in this case, we're only going to get the students with a grade greater than 60. And we can use operators, so we can do things like greater than, less than, and so on. So in that example, the next example there, we're saying where the class ID equals to and the grade is greater than equal to 50. So we're just narrowing it down further and only getting the data that we want. We can order by to put things into either ascending or descending order. So in this example, select the name and grade from the student, order by grade, and we've specified DESC, which means descending, which means it will go from high to low, high grades down to low grades. We can also group by, and group by collapses rows into groups. So in this case, we're looking at class ID and we want a count. So we're using a couple of things here. We're using group by to arrange them by class, and we're using count, which we'll see more of in a moment, to actually count how many there are in that class. So we select class ID, count student ID, so we're just counting how many times student ID occurs, how many non-null values there are. And then from student, so that's looking at the student table, and group by class ID means that everybody with the same class ID will first of all be grouped together, so all the rows will be grouped. And then all we want from this is the class ID, which would be the same for all of them, so it collapses down to 1, and the count, or how many there were, how many students there were in that class. So we might get something like class ID 1, count 20, and then will be class ID 2, count 30, whatever it might be. So group by works alongside these sum, count, and average things to make those have a little bit more meaning and helps organize the data. Now sometimes our data has been split into multiple tables. Remember, part of the normalization and the design of a database means that we actually have to split up the data. We've got no choice really to split it up by entity and then to split it until it's in the third normal form. So some of our data is not going to be on the same table sometimes. So we need to be able to pull together data from multiple tables. And the way that we do that is with joins. Now the only join you need to know about for this course is an inner join. And what that does is combines two tables, rows from two different tables, matching them on a related field. And there's a couple of ways of doing it. So the top one, we say select the attributes you want. Now of course these could be from either table, so if there's any confusion we should use this dot notation and put the table name in front of the attribute name. So there we've got student.name and class.className. So name comes from student table, class name comes from class table. And then we're saying from student, but we go on to say inner join class. So that means join those two tables together. And how do we join them together? How do we know which rows to match up with what rows? Well, we use the on statement. So, or the on clause of the inner join. So there we're saying on student.classID equals class.classID. So wherever we have a row on the student table that has the same class ID as a row on the class table, we'll join them together and effectively make a combined row with all the information from the student table and all the information from the class table. And of course they match. And they match in this case on class ID. They both have the same class ID. So we may get repetition there, for example. So we may get the same class multiple times in a row, but with different students each time. So if there's 10 students in a class, say class number 1, we'll get 10 lots of class, all the same class ID, class number 1, but with 10 different students. So that's combining the data back together again, and of course some of that data is redundant, so we're not actually storing that data because there's repetition now of the same class ID, but it does allow us to do the query where we're going to find out how many students there are, or whatever we want to do, get the information we want. In this case, we just want the student name and the class name. Okay, so we get that information and then we're finished. We don't store the redundant data. There is an alternative way of doing it, which I actually prefer myself. It's easier to remember. You can say the same thing, select student name and class name, but this time instead of saying from one table and saying inner join on, you just say from both tables, from student and class in this case, but you have to say where the thing matches still. So in this case we're going to say where the student class ID equals the class ID. And again it will do the same thing. It will match those two because you've specified more than one table in the from. This defaults to an inner join and pulls the two together and does the same thing as before. I just find that way a little bit easier to remember. It's kind of less syntax to remember, but either way is acceptable. So we've got some aggregate functions that work on multiple rows, and these are sum, count, and average. So count just counts how many rows or non-null values there are. Sum adds up a numeric field, whether it's an integer or real, it doesn't matter, it just adds them up. And average calculates the mean of a numeric field as well. So there's an example on the right hand side. We're selecting the class ID. So we're interested in the class ID, but we also are interested in the count of student IDs and the average grade. So there's 3 bits of information that we get given back. This all comes from the same table, it comes from the student table, and we're going to group by class ID. So first of all, we're going to separate all the classes out, so all the students in one class are separate from another class. Then we're going to count how many students there are in that class, and then we're going to produce the average. And our report, the results that we get given, will be grouped according to the class. So we'll get all the information for class 1, and all we get in this case would be a row for, say, class 1, a row for class 2, and each row would just say the number of students and the average grade. It doesn't give a row for every student or anything, for example, because we group by, remember, collapses the rows down. Okay, so continuing with data manipulation, how do we get data into the database in the first place? So once we've created it with DDL and defined the structure, we can start to put data in. So the insert command is used to do that. We say insert into whichever table we're interested in. And then we can list the attribute names, field names, and the values. And if you specify the field names or attribute names, They don't have to necessarily be in the same order as they were defined. If you don't specify the attribute names, then you have to make sure that the values you give are in the correct order in the way that the table was defined. You don't have to insert every single attribute if they're not mandatory. So that depends on the constraints that you define when you set up the table. But in this case, we're just adding 4 fields and giving the values of those 4 fields. Notice that text is in quotes here. If we want to remove a row, we say delete. And of course, we have to say what table we're removing it from and which row or rows we want to delete. So we can do more than one at a time if we want to. In this case, it's just deleting a single one because it's using the unique primary key of student ID. So delete from student where student ID equals something. We'll just delete one single row. And then update, we can change data that's already there. So we can update student, and to do that we say update student set some attribute to a value. And again, if you don't say where, it would apply to everybody, every single row in the table. So we use a where clause to restrict which one we're updating. In this case, we're using the primary key to make sure that we only get one record that we're going to update. It's a common cause of data loss if you forget to do the where. You can quite easily delete an entire table by mistake or change data in the whole table without realizing you've done that. So that's one of the common pitfalls. Number one is missing out the where on an update or delete. You also might forget to do the on clause in the inner join. So if you're doing it that way, remember to use the on to explain how the two tables relate to each other. You might use wrong delimiters, so text needs quotes, numbers don't, integers and reals don't. And dates and times for CIE believe they use the hash symbol, so they're, instead of being surrounded by quotes, they're surrounded by the hash symbols. And the insert column value mismatch, be careful to make sure that the values match up with your attribute list in the same order. And with the grouping, be careful not to have ungrouped columns with an aggregate. So all the columns must be aggregated or listed in the group by. Okay, so here's an example. We have a sports club called Riverside Sports Club. So it has members, and members can make bookings. A member can make many bookings over time, but each booking only belongs to one specific member. So in the member table, this is effectively our data dictionary, right? So, or our ER diagram, our entity relationship diagram. So we're defining all the member attributes. We have various attributes using different data types. So we've got integers, varchars, character, date, boolean, and real. And we specified that member ID is the primary key. And then we're looking at the booking table. We have, again, all the attributes with different data types. And we have a primary key of booking ID, but we have a foreign key of member ID. And remember, the foreign key goes on the side with the many in the relationship, in this kind of relationship, the one to many. So that points us back to the member that created the booking. So we're going to create the database. So create database, the Riverside Club, and we're going to create the first table, which is the member table. So create table member, brackets, and then all the attributes with their data types and the lengths if necessary. And we've specified the primary key at the bottom there with primary key followed by brackets and the attribute, which in this case is member ID. We close the whole brackets and finish with a semicolon. And then we're going to create the booking table. So using our DDL, create all the attributes, create a primary key again, but this time we're creating a foreign key. So we have to point back to the member table. So we're specifying the attribute on this table is called member ID. It's also called member ID on the member table. They don't have to be the same name so long as this link references them correctly. So foreign key member ID references the other table, which is member, and it's the field member ID on that table. Again, with DDL, this time we're altering the structure of a table using alter table, and we're choosing to add a new column which is called the email. So it didn't exist when we first created the table, but now we want to do it, so we have to use an alter. And it doesn't change existing data on the table, and all the rows that are already there will still be there with all the same data they had before, but we will have a new column for everybody as well called email, and it will have to start out as being blank for everybody that was already there, and then we may have to go back and populate it again later. So to create some data into our table, we're using insert into, so we're inserting into the member table, specifying the attribute list and the values in the same order, so they're matching up, we get everything in the right place. Notice the text in quotes and the date in hashes. So insert a couple of rows there, and we can carry on with that and add 2 more rows for Priya and Liam there at the bottom. Haven't shown the SQL for that, but assume that's been done as well. Do the same sort of thing for booking. Insert some records into there, dates and times in hashes, text in quotes. Booleans, you just write the word true or false. Okay, so if we did all that, then we would have these 2 tables containing these values so far. And then they reference each other, of course, because we have the foreign key relationship. Now we're going to do some DML, some queries on the data. Going to first of all select. So we want to find, in this case, junior members, the youngest first. So we're saying select the first name, surname, and the date of birth. They're the attributes we are looking for and want to have on the report. From the member table, where is junior is true, and order by date of birth. So remember, the default for order by is ascending, so it will go up. So there we've got Khan and we've got Aisha and Priya, and they're in order of date of birth. It's the youngest first and the oldest or largest number effectively last. That's ascending order. Alright, we can also filter by date and time. So again, you're just going to put in the where clause, how you want to restrict the data, and remember that dates with hashes and times with hashes, and that's what you'd get. So you run a couple of queries to restrict the rows that you get back. Let's use group by and some of the aggregate functions. So this time we want to look at a summary of each member's booking activity and how much they've been spending. So we're going to select the member ID and count bookings. So for every member, we want to know how many bookings they've made, and sum the fees. So add up all the fees they've spent and average the fees that they've spent. So selecting the member from the booking, we're grouping by member ID. So remember, members can make many bookings, but all we want to see is the aggregate information, the count, the sum, and the average for them. So in this case, we look at on the right hand side, we get the results. One member ID 1 has made 2 different bookings, so the count was 2. They spent a total of 17, which is an average of 8.5, and so on. So the group by, remember, collapses rows down such that we just get 1 row per member in this case. And note that member 4 is not there, even though they were created, and that's because member 4 didn't make any bookings at all, so they wouldn't appear in a group. You can't be a member of a group by if there's no entries at all in the booking table. So it just doesn't exist. Okay, so combining tables together. So as I say, there are times when the data isn't on the table you want, so we have to join more than one table together. In this case, we're selecting the first name, surname, the court name, and the booking date, but they come from two different tables, the booking table and the member table. And in this example, we're using the inner join method, where we specify the table we get some of the data from, which is member, and then inner join on booking, which is where we get the rest of the data. And we're matching those two tables up row by row, where the row has a member ID on the member table that matches with the member ID on the booking table. And then we're ordering the whole thing by the booking date. And again, without specifying it, the default is ascending, so this is going to go up from lower numbers to higher numbers. And there we go. So we have our results shown below. That's what we would see. All the members and the court names and the booking dates, information coming from more than one table, and this is enabled by having the join. And of course Liam's missing again because Liam hasn't made any bookings yet, so when the join happens there is no match, so there will be no information for Liam. Now we're doing a bit of maintenance on the data. So in the first case, Tom is paying for his booking, so we need to make sure that paid is set to true. So all we're going to do is say update booking and then use the word set and the attribute that needs to be changed. So update booking set paid equals true, where booking ID equals 2. Of course that where is important because I want to make sure we made the right person set to paid and not everybody or the wrong person. And on the right hand side we've got a delete, so somebody cancelled a booking, so we need to get rid of it, and we just say delete from the table booking where booking ID equals 5. So you can use anything in the where clause so long as it helps you identify exactly what you want to delete. It's often the primary key if you're just deleting one record or updating one record. Alright, recapping. So we can create the database and the tables first of all. We set up all the attributes and the relationships, the primary key definition, the foreign key definitions. We can alter tables, adding to them. Remember, this is still DDL. We're affecting the data dictionary, the structure, not the actual data within the tables. And then we can do DML, where we're inserting data into the tables and then doing queries on it. We can filter, sort, summarize, and combine data. And we can update and delete data. Okay, and that's what you need to know for database DDL and DML in section 8.3 of the spec. Thank you very much.